Welcome to the Explainer. Have you ever seen an AI do something absolutely brilliant, like pass the bar exam, and then turn around and do something, well, incredibly dumb? Today, we're diving into this exact mystery, the AI paradox.
This is a real puzzle, and it's something that even top minds in the field, like AI pioneer Ilya Sutskever, are scratching their heads about. It's this bizarre contradiction that he and others are trying to unravel right now.
So let's break it down. On one side, you've got these AIs performing at superhuman levels. We're talking acing some of the hardest professional exams out there. But then, on the other side, they just stumble. They fail at surprisingly simple tasks that you and I wouldn't even think twice about.
Okay, so this brings us to what we're calling the AI performance paradox. Is it a case of mistaken intelligence? Let's dig in and see what's really going on here.
You know, the source for this gives a perfect, almost comical example. Imagine this. You ask an AI to fix a bug in some code. It says, "Oh, my bad," and fixes it, but in the process, it creates a new bug. So you point that one out, and what does it do? It apologizes again and brings back the first bug. You're just stuck in this endless, frustrating loop. It really gets to the heart of the problem.
And this isn't just some funny little quirk, right? It has real-world consequences. The big takeaway here is that these models seem way smarter on paper than their actual economic impact suggests. They're acing all these tests, these evals as they're called, but that performance isn't translating into real-world value, at least not yet.
So this is the million-dollar question, isn't it? What is going on here? Why is there this huge gap between acing the exam and, well, actually doing the job?
All right, so let's start hunting for the cause. The evidence seems to point to a really interesting idea. What if we're just teaching to the test? Maybe the problem isn't the student. Maybe it's the teacher. To get this, we need a quick look at how these things are trained. In the old days, a few years ago, it was all about pre-training. The philosophy was pretty simple. Just throw the entire internet at it. The data is everything, you don't even have to think about it. But now we've moved to something called reinforcement learning, or RL. And with RL, you do have to think. Researchers are hand-picking specific tasks to train the AI on.
And here's where it gets really juicy. Where do you think researchers get ideas for these training tasks? You guessed it, from the exams themselves, the evals. They look at the test and say, okay, I want my model to crush this. So they create training exercises that look an awful lot like the final exam. It's basically teaching to the test on a massive scale.
This leads to a really powerful, kind of provocative idea. We talk a lot about reward hacking in AI. This fear that the AI will figure out a shortcut to get the prize without actually learning the lesson. But what if the AI isn't the one hacking the system? What if it's the humans, the researchers, who are so focused on getting a high score that they're the ones gaming the system, even if they don't mean to?
Okay, to really nail this down, the source gives us a fantastic analogy. Let's call it the tale of two students.
First up, you have student number one, the grinder. This student is all about brute force. We're talking 10,000 hours of practice. They've seen, solved, and memorized every single problem in the textbook. And you know what? It works. They become one of the absolute best on the test. But they don't really have any general taste or good judgment.
Then you have student number two, the natural. This student only puts in, say, 100 hours, but they've got that it factor, that spark. They can see a problem they've never encountered before and just figure it out. They generalize their knowledge. They develop real taste, real judgment.
And there it is. That's the perfect way to think about our current AIs. They are the ultimate grinders. They've been trained on an unimaginable number of problems, but they lack that flexible, deep understanding of the natural. They can give you the right answer, for sure, but do they really get the question? That's a whole other story.
So if just making a better grinder isn't the final answer, what's next? This brings us to the search for true learning, for something beyond just brute force.
The magic word here is generalization. It's what the natural student has. It's the ability to take what you've learned in one situation and apply it to something completely new and unfamiliar. You and I do this all the time without even thinking about it. For AI, it's the holy grail.
And this hunt for generalization is actually pushing the whole field of AI into a new era. Think about it like this. For the last few years, say from 2020 to 2025, we've been in the age of scaling. The recipe for success was simple. Just add more data and more computers. But now, we're swinging back. We're re-entering an age of research. But this time, we're hunting for those fundamental breakthroughs, like generalization, with some seriously big computers at our disposal.
You know, this whole quest is so fundamental, it's actually making us rethink the ultimate endgame, AGI or artificial general intelligence. What could it really be?
So when we hear AGI, we usually picture this all-knowing finished product, an AI that can do anything and everything. But think about it. Is that even how we work? Humans aren't like that at all. Our superpower isn't knowing everything from birth. It's our incredible ability to learn. And Sutskever offers this really cool, different way of looking at it. Instead of an all-knowing oracle, what if the goal is to create something like a super intelligent 15-year-old? Someone who is brilliant, incredibly curious, and just ready to learn.
And that completely reframes the entire mission, doesn't it? The real game changer isn't an AI that knows everything. It's an AI that has a phenomenal capacity to learn anything, way faster and deeper than any human ever could. The goal is to build the ultimate student.
And that leaves us with a pretty deep question to chew on. If we succeed, if we build this next-generation AI that learns like a person, only better, what's the very first thing we should teach it? The answer to that could shape everything that comes next. That's all for this explainer. Thanks for joining us.